At this part, we are going to introduce WLAN security technologies. And the first is about the SSID verification and hiding. Since the APs will broadcast their SSID to advertise the existence of WLANs, so wireless STAs can discover WLANs by scanning the network. And to prevent unauthorized users from searching for WLANs by SSID and establishing connections with the WLAN, the SSID broadcast function of APs can be disabled to hide wireless SSIDs. If the SSIDs are not broadcast in beacon frames, when a wireless SDA scans and searches for available networks, they cannot find the SSID we have hidden and can improve the security of the network. But if we hide the SSID, and how can we connect to the WLAN? Of course, you should manually enter the SSID in the equipment. And we assume that in your home network, you have already disabled the SSID broadcast. And someday, your friends come to visit and they want to connect to the WLAN. So they will ask you for the SSID. And you can tell them, okay, the SSID is Ruijie. And they can manually enter this SSID in their, for example, mobile, and to send a request to the AP. And after getting this request, AP will check if the SSID of the STA is the same as that of the AP. If it's different, AP will deny the access of the STA. But if it's the same, AP will allow the access requirement. So we can think that an SSID is a simple password that provides password authentication to ensure security. This is about the working principle of it. And then let's see how to configure it. On the feed AP mode, you should configure it on the AC. Firstly, disable the SSID broadcast function in the WLAN config. WLAN config 1 Ruijie is WLAN1, which SSID is Ruijie. No enable broadcast SSID. We have disabled the SSID broadcast. And then AP group Ruijie. So we have entered the configuration view of the AP group. And firstly, disable this command. No interface mapping 110 and reconfigure it. Pay attention here, it's very important. Only in this way we can make this function take effect. While on the fed AP mode, configuration is done on the APs, right? .11 WLAN1, no broadcast SSID, so we have disabled it. And then reconfigure the mapping between WLAN ID and the interface. The interface .11 radio 10, no WLAN ID 1, and reconfigure it. In this way, it will take effect. Okay, this is about the working principle and the configuration of SSID hiding and the verification. Then let's see the WLAN security mechanism. To enhance WLAN security, wireless devices provide the authentication and the encryption mechanisms. For the authentication mechanisms, user identifier authentication is conducted to allow only authorized users to use network resources. So from here, we can know authentication is used to identify if the user is allowed to use the network or not. Right? While next, encryption mechanism, wireless link data is encrypted to ensure that data of wireless networks is received only by designated users. So different from authentication, encryption is used to protect the security of data. So we can see that authentication is about users and encryption is about data. Okay, after knowing this, so how can we authenticate users or how can we encrypt data? Then let's see. Firstly, for the link authentication, we have open system and shared key authentication. We have already introduced it in the former section. And then is the access authentication security policies. First is open. It's a link authentication, open system authentication, right? And they do not offer any access authentications, and the data encryption is not encrypted. Next, WEP is a shared key authentication or open system authentication. The data encryption uses the algorithm which is RC4. And next is WPA, WPA2. It supports open system authentication. And for the access authentication algorithms, could use PSK, PPSK, 802.1x. And for the key negotiation, it's used PDK, GTK, and the data encryption algorithms. Here we can choose is TKIP and CCNP. Okay, after taking an overview of it, then let's see some details. Here, an STA connects to a WLAN without key verification because it's an open system. And the authentication involves two steps. First is the authentication request. You can see the STA will send a request frame and verify that algorithm identifier is open system and the process sequence number is 1. After receiving the request frame, the AP will send a verification frame, and actually it's an authentication response to ensure that, okay, the result is succeed, because you can say verify the result of the request, and since there is no authentication here, so the result is succeed. It's quite easy, right? The open system authentication. And the whole process of the open system authentication is shown here. Firstly, STA will send out a probe request, and then each AP will send a probe response, means you can access the network through me, right? So receiving the response from APA and APB, STA will evaluate the response and select the optimal AP. Actually, they will compare the power strength. And then STA selects APA. So STA send an authentication request to the APA, and APA will feedback a response to confirm the authentication results and register STA. So until now, STA has finished the open system authentication with APA. Okay, and next is about data encryption. Here it shows us some data encryption algorithms. First is RC4. RC4 is a stream encryption algorithm with a variable key length. Encryption and decryption use the same key. It uses the same key to encrypt and decrypt data. So it is also a symmetric encryption algorithm. An encryption algorithm is used in WEP. Okay, and next, AES, Advanced Encryption Standards. So from the name, we can figure out that AES has a higher security level than RC4. These encryption standards were set by the National Institute of Standards and Technology in 2002. And in 2006, AES became one of the most popular symmetric key encryption algorithms. Okay. And next, wireless encryption protocols. First is TKIP. TKIP is a shield that wraps around existing WEP passwords. So you can think it's a strengthening of WEP. TKIP consists of RC4 algorithm and the encryption engine same as that used by WEP. The password in TKIP contains 128 bits. So it has extended the length of the key or of the password, which solves the problem of an excessively short key length existing in WEP. Because we know that no matter we use a key in the network or the password of our accounts, the longer the key is, the safer the network would be. Right? This is also a very important reason that why TKIP is more safer. Okay, and next is CCMP, counter code with cipher block chaining message authentication code protocol. CCMP is mainly composed of two algorithms, CTR mode and the CBC MAC mode. CTR mode is an encryption algorithm, and the CBC MAC is used for message integrity operation. CCMP also uses the AES algorithm and is most secure. Okay, after taking the overview of these algorithms, then let's see some protocols. First is WEP protocol. It encrypts wireless transmission data to prevent unauthorized eavesdropping and WLAN intrusion. The WEP encryption algorithm uses RC4 algorithm to encrypt user data. A STA shares a key with an AP, and the standard key length is 40 bits. If it's used in the open system authentication, STA can connect to a WLAN without key verification. But for the shared key authentication, an STA sends an authentication request to AP. AP returns a reply in plaintext. And after receiving the plaintext, the STA will encrypt the plaintext by using the pre-shared key and send the result to the AP. After receiving that, of course, AP will verify that if the result is the same as a local one. If it's the same, so it will accept the request. Well, if it's different, so it will be denied. This is a WEP introduction. And since we have mentioned the WEP many times, so let's see the encryption and the decryption process of the WEP protocol. You can see, firstly is the encryption process. Here is a key, right? The pre-shared key, and the key will be calculated by the RC4 algorithm together with IV here. IV is the initialization vector, and the result would be a key stream. And by using this key stream, we will encrypt the plaintext. We will encrypt you can see the data. So after exclusive OR operation, what we will get is a ciphertext, and the ciphertext will be combined with IV and get the encrypted data frame. So the encrypted data frame consists of two parts. The first part is the IV, and the second part would be the cipher text. Okay, and it will be transmitted to the receiver. And after receiving that, you can see here, this is encrypted data frames we have received. So we will divide it into two parts. First is IV, and another is a ciphertext. So you can see this is a ciphertext, and of course we will get an IV. Right? IV is plaintext. Okay, and the ciphertext here will be exclusive OR operation together with a key stream. The key stream is actually same as the key stream here, and we will get the plaintext. This is a decryption process of WEP protocol. Okay, and then next, here comes the WPA Security Protocol. The IEEE 802.11i working group is committed to the development of the new generation security standards to reduce defects of WEP encryption and enhance the WLAN data encryption and authentication performance. The Wi-Fi audience proposes the Wi-Fi Protect Access System as an alternative to WEP. WPA is not an IEEE standard, but a part of IEEE 802.11i draft. So the standard is WPA2, actually. It is a subset of the IEEE 802.11i security standards. And about the WPA, here it shows us some features. First, it supports TKIP and AES. It supports IEEE 802.1x and the PSK authentication modes. It inherits the encryption principle of WEP and eliminates the shortcoming of WEP. It uses dynamic keys. The IV key starts with 0 and increases with each subsequent frame. So since the key is dynamic, it's not a fixed value, so we can improve the security level, right? And it supports message integrated check to prevent packet forgery and support automatic key update. So if we use WPA, about the authentication, it uses 802.1x and EAP authentication to conduct extensible authentication through a third-party AAA server, for example, a radio server. Right? And about the encryption, WPA uses new TKIP authentication and encryption mechanism. Uses a radio server to allocate key for data encryption. This mechanism exists only in enterprise mode and is not supported by WPA PSK. Okay, this is about WPA Security Protocol. And as we have just mentioned, since it's not a standard, it's just a draft. So another is called the WPA2, which is defined by 802.11i. It's a second version of WPA and supports the AES algorithm. It requires hardware for support and use CCNP. WPA2 includes WPA2 PSK, which is a shared key mode, and WPA2 radios, which is a certificate mode. Except that WPA2 supports two encryption methods, AES and TKIP. Okay, since it supports TKIP, so it's more secure. This is about the technologies we introduced at this part. And next, let's see a question. Okay, the question is that which of the following are the features of WPA? A. Supports TKIP and AES. B. Cannot prevent packet forgery. C. Uses static key. D. Supports IEEE 802.1x. So, which of these choices you think are the feature of WPA? Actually, A and D are the feature, but B cannot prevent packet forgery. It's false, right? By using WPA, we can prevent. And C, use static key is false because we use dynamic key. Okay, so here we choose A and D. Okay, that's all for this part.